In section 6.7, we study 3 topics: simple interest, compound interest, and credit cards. Simple interest is very simple to explain. As the name implies, here's the definition of simple interest. And that is a simple interest, I, on principal P, invested for T years, at interest rate R, is given by the product of P times R times T. So the interest is the principal times the rate of interest times time in years. So here's the first question. What is the simple interest on $4,300 invested at an interest rate of 4% for 1 year? When we follow the formula I for interest equals P times R times T, then the principal is $4,300 and the interest rate is 4%, and the time is 1 year. That's where the 1 comes from. So then it is 4,300, and 4% is 0.04 times 1, and that product is equal to 172. In other words, the simple interest for this amount, $4,300 at an interest rate of 4% for 1 year, equals $172. Exercise 2 is very similar. What is the simple interest on the principal amount of $4,300 invested at interest rate of 4% for 9 months? So the only thing that's different about this exercise is that the time is given in months in terms of years. Now, 9 months is equal to 9/12 of a year, because 1 year has 12 months. So therefore, the interest is equal to P, the principal of $4,300, times the interest rate of 4%, times 9/12. This is equal to $4,300 times 0.04 times 0.75 for 9/12, and this amount equals $129. So the answer here is $129. Exercise 3 is a guided solution. The glass nook borrows $4,800 at 5.5% for 30 days. Find A. So in this guided solution, the glass nook borrows $4,800 at 5.5% for 30 days. There are 2 parts. Find the amount of simple interest due, and B, the total amount that must be repaid after 30 days. So everything is as before. The principal is $4,800. The interest rate is 5.5%. Now the time we have in days, and since there are 365 days in a year, we now have 30 divided by 365 for the time in terms of years. And then the calculations are as follows: $4,800 times 0.055 times 30 divided by 365, which is equal to $21.70. So then the amount for part B that must be repaid excuse me, after 30 days is the original $4,800 that was borrowed, plus $21.70, which is equal to $4,821, $821.70. The next topic we'll be discussing is called compound interest, and that is when interest is paid on interest. We call it compound interest. You may have heard this before. So this is a type of interest usually paid on investments. Suppose you have $5,000 in a savings account at 6%. In 1 year, the account will contain the original $5,000 plus 6% interest of $5,000. Therefore, the total in the account after 1 year will be 106% of 5,000, or 1.06 times 5,000, or $5,300. So that's what will be in the account the first year. Now, suppose that the total of 5,300 remains in the account for another year. So now, at the end of the second year, the account will contain the 5,300 plus 6% of 5,300. In other words, the total in the account will be 1.06 times 5,300, or 1.06 times 5,300, or $5,618. In other words, we now compute 106% of 5,300 instead of 5,000, because the interest is included now in the new principal. And so for the third year, we now compute 106% of 5,618. So the amount that is in the account will continue to go up. So let's apply that to an exercise here. Find the amount in an account of $3,000 invested at 2%, compounded annually for 2 years. So for the first year, the interest will be equal to the $3,000, and the total amount rather. Following the example above, the amount in the account after 1 year is 102%, 2% plus 100, 102% of $3,000, or 1.02 times 3,000 is equal to 3,060. So that's the amount after 1 year. After 1 year. Now, we take this amount, $3,060, and multiply that by 102%. Or 1.02 times $3,060. That's equal to $3,121.20. So it's after 2 years. So then our answer to the question, find the amount invested at 2% for 2 years, is $3,121.20. And even though this was not asked in this particular exercise, you can find out for yourself how much money will be in the account if it's invested for another year at 2%. What would be the end of the year, or what would be for the investment after 3 years. So this after 2 years, after 3 years. I leave it up to you to determine that. Thinking back to the previous problem, what the question had been, how much is in the account after, let's say, 15 years? Would you have to repeat these calculations 15 times in a row? And of course, that's one way to do it, but fortunately, there's a formula for that, and it's called the compound interest formula. And here it is. It's as follows. If a principal amount of P has been invested at an interest rate R, in decimal notation by the way, compounded n times a year in T number of years, it will grow to an amount A, given by A equals P times 1 plus R divided by N to the N times T power. So it's N times T here as an exponent. Okay. So that's a formula that you may have seen before, but you will see it again more than once for sure. And so let's try that out on an example here. A couple invests $7,000 in an account paying 6 3/8%, compounded semi-annually. Find the amount in the account after 1.5 years. The best thing to do here in these types of exercises is to clearly state what the various letters represent. So P in this case is equal to 7,000. R, the interest rate, is equal to 6 3/8%. Since it says it's compounded semi-annually and equals 2, and the amount of time is 1.5 years, and it was 1.5 years. Now we are ready to substitute these values into the formula. And again, the formula is equal to A, the amount after 1.5 years, is equal to P, the principal, times 1 plus R divided by N to the N times T power, which will be then P is equal to 7,000 times 1 plus, and the interest rate in decimal format is 0.06375 divided by 2. Remember, N was equal to 2 because it's compounded semi-annually, to the N times T, or 2 times 1.5 power. So now we're going to use order of operations. We perform the operations inside the parentheses first. In other words, we divide 0.06375 by 2 and add 1 to it, which will be then 7,000 times 1.031875, and 2 times 1.5 is equal to 3. So we raise this expression to the third power. I would encourage you to use your calculator to make sure you come up with the same expression for inside the parentheses. Now, raising this to the third power, we can obviously multiply the number 1.031875 3 times by itself, or most of you probably have your phone calculator, and I think I explained this to you before, but it has a built-in scientific calculator. In other words, you can raise something to a certain power. So let's say I put in the number 1.031875 in my calculator. Then I press the X to the Y key, and then input 3 for the exponent, and then touch the equal sign, I have now 1.09878705, etc. Okay? So I'm going to write this number down. That's equal to 7,000 times 1.0987. I'm going to truncate, I'm going to round it down for the rest. So in other words, now multiply this amount that you see in the display, oops, I multiply that by 7,000. And when I do that, the result is 7,690, and I'm going to 938, and we're going to round it to the nearest cent, which is equal then to 7,690.94. So this is the amount in the account after 1.5 years. And again, I would encourage you to perform the calculations yourself. At least now you know what you're supposed to get on your calculator, and just proceed with that the best you can. And I'm sure if you practice it enough, you come up with the correct answer also. So here you apply several things, including order of operations. Inside the parentheses first, operations there, we do the division first, and then we add. Then we do exponents. In this case, we raise this number to the third power. And again, there are different ways to do it. I showed you how to do it on my calculator, the iPhone, but Android phones have similar calculators, so it'll be pretty much the same. And just explore your phone calculator that way. There's usually a way to do that, to raise something to a certain power, and that you come up with the correct answer. Next, we'll talk about credit cards. Credit cards are wonderful, but they can also be a problem. According to nerdwallet.com, the average credit card debt among U.S. households with such debt was $16,883 per household in 2016. That is certainly concerning. And the money you spend through the use of a credit card is not free money. There's a price, and that's interest to be paid for the convenience of using a credit card because you're using other people's money. And the balance carried on a credit card is a type of a loan. Comparing interest rates is essential if one is to become financially responsible. A small change in interest rate can make a large difference in the cost of a loan. When you make a payment on a credit card balance, do you know how much of that payment is interest and how much is applied to reducing the principal? That's an important question, so check it out. And in your credit card statements, if you use credit cards, it normally tells you that. So here we're looking at a particular exercise. Credit card. After the holidays, Samantha has a balance of $4,867. So the problem statement continues. Part A. Many credit cards require a minimum monthly payment of 2% of the balance. What is Samantha's minimum payment on a balance of $4,867.59? Round the answer to the nearest dollar. Well, 2% of $4,867.59 is equal to 0.02 times $4,867.59. So this is equal to 97.3518, and we are supposed to round it to the nearest dollar, so there would be $97. That's a minimum payment, minimum monthly payment. Part B asks a different question. Find the amount of interest and the amount applied to the reducer principal in the minimum payment found in Part A. In other words, how much of the $97 goes towards the principal, and which amount what amount is interest? So remember, the amount of interest is the principal times the rate times t, the time, and the principal is $4,867.59. The annual interest rate is 21.3%, 21.3%, and the time is t equals 1 month or 1/12 of a year. 1 month or 1/12 of a year. Therefore, the interest is equal to 4,867.59 times 0.213 times 1/12, which is equal to 86.3997. So you round it up to $86.40. So that part of a $97 payment is towards interest. That's the interest. Then the amount that's applied to the principal is the difference between what she's paying, $97, minus the amount that goes towards the interest, $86.40, which is equal to $10.60. So $10.60 goes towards the principal, towards the principal amount. So in other words, most of what she's paying out of her $97 minimum payment goes towards interest. Only $10.60 is towards the principal. In other words, it's going to take a long time to pay off the principal if you make only minimum payment. That is the message here. So in other words, if you're offered you only have to pay minimum, that comes with a tremendous cost. It's going to take you that much longer to pay off your balance. Okay, so that's maybe you already knew all of that, but maybe some of you hear or see this for the first time. So if you can pay more than minimum, go for it. It'll help you pay off your balance much faster. Another way of saving money is Part C, and that says if Samantha had transferred her balance to a credit card with an APR of 13.6%, how much of her first payment would be interest, and how much would be applied to reduce the principal? Okay, so it's the same formula as we had here for the interest. The only difference is now we have a different interest rate. So now for Part C, the interest rate is equal to 13.6%. So we use the same expression for the interest. The interest is equal to 4,867.59 for the principal times the interest rate, which is now 13.6%, or 0.136, times 1/12. So it's equal to 55.166002. So we say that's approximately equal to $55.17. So that is how much interest she pays out of $97. So the amount that goes towards the principal, again, would be the difference between a payment of $97 minus what goes towards the interest. So it's $97, the minimum payment, minus 55.17, which is equal to 41.83. So now $41.83 is goes towards the principal. That's almost 4 times the amount than in the previous example with a higher interest rate of 21.3%. So by changing to a lower interest credit card, much more goes towards the principal than in the other case. So it's a huge difference, almost 4 times that amount towards the principal. Of course, the numbers matter, but I just want you to understand the idea behind it and the power of having a lower interest rate on your credit card, especially when you're making minimum payments. If you pay off every month, that's something I highly recommend. We do that. We've done that for years. If you can pay off the whole balance, of course, then the APR doesn't really matter because you never pay any interest. But if you're stuck somehow, or if you do pay interest somehow, make sure you get a credit card that has a lower interest rate, if that's possible. In Part D, we are asked to compare the amounts for 13.6% from Part C with the amount for 21.3% from Part B. So the first thing we can say is that at 13.6%, the principal was reduced by $31.23 more than at the 21.3% interest rate. That's one part. And the interest at 13.6% is $31.23 less than at 21.3%. This is the end of section 6.7, and it concludes all of chapter 6.